Hello everyone, we are Victoria Ramirez, Ariel Lauper, Christopher Tangonen, and Edward Torres. And today we are presenting our project DynamiCode, an adaptive space repetition-based platform for learning data structures and algorithms. Preparing for technical interviews often means juggling dozens of DSA problems. Platforms provide practice, but they don't guide learners on what concepts they're forgetting or when to review them. So learners either try to track everything manually or move on and lose earlier knowledge, leading to inconsistent mastery and unnecessary stress. Spaced repetition has existed for over 20 years, but most approaches focus on optimizing review timing for individual flashcards. There's very limited support for concept level relationships across multiple coding problems, which means current tools still miss the bigger picture, learning interconnected topics in a lasting way. DynamiCode takes the proven benefits of spaced repetition but applies them differently. Instead of scheduling one problem at a time, we use topic meta tags to understand how problems are related and schedule reviews at the category level based on the user's performance and mastery. If someone does well in a topic, their next review is spaced further out. If they struggle, DynamiCode surfaces more problems within the same concept to reinforce understanding. This creates a personalized review plan that strengthens the entire knowledge structure, not just single items. So DynamiCode isn't just another spaced repetition app. It's a smarter, concept-driven approach to mastering coding interviews.
Throughout DynamiCode's development, we used Gmail, Zoom, and Discord for communication and employed GitHub projects for task management. We utilized the modern framework Next.js with React plus TypeScript, as well as Supabase to manage the PostgreSQL database and handle authentication. Finally, Vercel was used for deployment along with DigitalOcean Droplets to host the code execution tool Piston. Although we initially planned to build a separate backend using microservices, we pivoted to Next.js server-side rendering to lower costs and reduce complexity while still ensuring secure database interactions. Additional challenges included correctly separating all logic into client and server components to ensure security and efficiency, and adapting to ongoing changes within Supabase auth, which required investigation beyond their documentation for a successful setup.
To begin this demonstration, we'll start on the login page, where a user can sign up, log in, or reset their password. The app also includes full authentication and authorization. With that being said, let's log in and be presented with our dashboard, providing several user-related stats. Now, our point of interest is the study stack, where active categories are highlighted in blue and notification bubbles indicate how many problems remain within the category. Let's select a problem to move to our coding page, where on the left is our problem description, examples, as well as constraints. On the right is our Monaco-based code editor. We've also incorporated Excalidra's whiteboard, allowing users to draw out their solutions. Now on the bottom is a button for running code powered by Piston. Now right now, it'll show a global error. However, if we were to compose correct code, you can see that test cases do run. Now, after a user has attempted a problem, they have to rate their performance, common in most spaced repetition systems. Ours, however, is a little different. So if we were to rate it at 0 stars, it signals to the system that reinforcement is required and could resurface additional problems within the category. If we were to rate it at 3 stars, it gives a neutral outcome, keeping the problem active within the category. And if we were to rate it at 5 stars, it moves the user forward in progression, closing out this problem for this iteration. Now, we'll use an end-to-end test to demonstrate how the system behaves through the initial learning phase. We'll create a new user, log in, and then move over to our dashboard. New users only have a single selected category available in their stack. When they complete half the problems, they will unlock the following category. To show this, we'll begin with our first problem and resolve 3 problems in total. So you'll see that we've unlocked a new category at our third problem solved. Now let's go back to our dashboard to confirm that the sliding window category has activated along with its 6 associated problems. Now, whenever we're able to resolve all problems within the set is whenever it gets scheduled. So to confirm this, let's go ahead and run through those final 3 problems. And you'll see that the category is scheduled. Again, to confirm this, let's go back to our dashboard, and you'll see that the stack category and its problems have all been resolved, and that it is scheduled to reactivate on December 17th. Alternatively, you can also view this at a month scale on our calendar page. Now, to close out our tests and perform clean test isolation, we have this delete account button, which allows a user to delete all user-related data within our database.
Overall, our platform aims to reduce mental overhead, improve consistency, and make learning more efficient by applying spaced repetition to a set of problems. During development, we explored new technologies, rapidly prototyped features, and deepened our understanding of state management. This project helped us grow technically and taught us how to design solutions that support long-term learning. While we built a working prototype within our timeframe, we already had several improvements planned. First, we want to add a daily limit on problem attempts so users give more thoughtful ratings. Next, we plan to complete all interface functionality. Finally, there is a research opportunity to compare the effectiveness of our scheduling algorithm against SM2 to better understand their impact on long-term knowledge retention.